We're going to talk about the molecular orbital theory and how to define bond order for the molecule. The molecular orbital theory is a model that describes the behavior of electrons delocalized through a molecule in terms of the combination of atomic wave functions. So the molecular orbital theory explains the bonding in molecules and can describe the resonance of the molecule. The molecular orbital theory uses a specific energy filling up order. So there's a filling up order for atoms between lithium and nitrogen, and there's a filling up order for atoms between oxygen and fluorine. The molecular orbital theory also defines the bond order. Bond order equals the number of bonding electrons minus the number of antibonding electrons divided by 2. This is the specific filling up order for atoms between lithium and nitrogen. The orbitals that don't have stars on them are called bonding orbitals, and the electrons in these orbitals are called bonding electrons. The orbitals that have stars on them are called the anti-bonding orbitals, and the electrons in these orbitals are called anti-bonding electrons. We draw the molecular orbital diagram by showing the first atom on the left that's involved in the molecule, and we draw its electron orbital diagram. Then we put the second atom on the right and draw its electron orbital diagram, and the middle will describe the bonding between the two atoms. This is the diagram or the filling up order for atoms between oxygen and fluorine. If you notice, there's a slight difference at this energy level. We still do the same thing. The first atom's electron orbital diagram goes on the left. The second atom electron orbital diagram goes on the right. And the middle will describe the bonding between the two atoms. Let's see an example. Draw the molecular orbital diagram of N2. Predict its bond order and whether it's diamagnetic or paramagnetic. I like to always start off with the valence electron count. Nitrogen is in group 5, and we have 2 nitrogens. So there's a total of 10 valence electrons. I like to also have my electron configuration. The periodic table will help us determine how many total electrons does nitrogen have. Its atomic number is 7, so a neutral nitrogen will have 7 electrons. 1s2, 2s2, 2p3. So that means the left will have 1 nitrogen, the right will be another nitrogen, and the middle would be the molecule N2. So we're going to start off with the orbital diagram that's on the left. 1s2, 2s2, 2p3. And on the right, 1s2, 2s2, 2p3. Now we want to describe the bonding that happens in N2. We're going to pull 1 electron from the left and 1 electron from the right and put it in the middle. So 1 from the left, 1 from the right, 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 left, right, left, right, left, right. So we know we have all of our electrons. We want to make sure that there are going to be 14 electrons in the middle. 2, 4, 6, 8, 10, 12, 14. So we have all 14 electrons. The next thing we want to do is determine the bond order. The bond order is bonding electrons minus anti-bonding electrons divided by 2. So the bonding electrons are going to be 2, 4, 6, 8, 10. Anti-bonding electrons, 2, 4. So 10 minus 4 is 6. 6 divided by 2 is 3. So this suggests that there are 3 bonds between nitrogen, and our valence electrons tell us that this Lewis structure should have a total of 10 electrons. So each bond is 2 electrons, so there are 6 electrons, 8, 10. We also have to determine whether it's diamagnetic or paramagnetic. We want to examine the electrons in the middle and see if we have any unpaired electrons or if all of the electrons are paired. So these are paired, these electrons are paired, all of the electrons in the middle are paired, so this refers to a diamagnetic molecule. Let's take a look at another example. Draw the molecular orbital diagram of F22+, predict its bond order and whether it's diamagnetic or paramagnetic. I always want to start with my valence electron count. There are 2 fluorines, and fluorine is in group 7. So 2 times 7 is 14, but that 2 plus suggests that it gives up 2 electrons. So I have a total of 12 valence electrons. I know that this molecule is made up of 2 F plus atoms. So I want to draw the complete electron configuration of the F plus atom. So a neutral fluorine has 9 electrons. F plus means it gives up 1 electron, so it has a total of 8. So 1s2, 2s2, 2p4. So I have an atom of F plus on the left, an atom of F plus on the right, and in the middle I have the molecule F2, 2 plus. I'm going to go ahead and draw out the electron orbital diagram. 1s2, 2s2, 2p4. And on the right, 1s2, 2s2, 2p4. I'm going to go ahead and pull an electron from the left and an electron from the right and put it in the middle. So 1 from the left, 1 from the right. And 1 from the left, 1 from the right, 1 from the left, 1 from the right, 1 from the left, 1 from the right, 1 from the left, 1 from the right. All right, so the middle should show 16 electrons. So let's see if we have 16. 2, 4, 6, 8, 10, 12, 14, 16. So I'm ready for my bond order. Bond order is the bonding electrons minus the anti-bonding electrons divided by 2. So let's count the bonding electrons. 2, 4, 6, 8, 10. Anti-bonding electrons, 2, 4, 6. So 10 minus 6 is 4. 4 divided by 2 is 2, which means that there are 2 bonds between the fluorine atoms, but we have a total of 12 valence electrons. So each bond is 2 electrons, 2, 4, 6, 8, 10, 12. We don't want to forget the bracket because this is a charged molecule. We want to now determine whether this is diamagnetic or paramagnetic. We want to examine the middle and see if all of our electrons are paired. These electrons are not paired. So because we have unpaired electrons, this is called paramagnetic molecule. Good luck and keep practicing.